For the second exercise, we will use a special data set. It's called people XLSX. It's an Excel file with this people data. You can, if you take my course officially, you have it already. It's provided. If you just watch the video, you can download it using description under this video. And then this is how it looks like inside. So you can see that this data set consists of 32 rows. It's 33 because the first row is variable names. So 32 rows. It's different people. These people are from two different regions. It's Scandinavian region and Mediterranean region. And then we have half females and half males. And then you can see that we have the following characteristics. We have height, weight of people, height in centimeters, weight in kilograms, hair length, shoe size, age, income, beer consumption, wine consumption, sex coded -1 for male and +1 for female. It's a kind of dummy variable. How well they swim, the region they came from, again, -1, it's for Scandinavia and +1 for Mediterranean. Then finally, IQ of these people. I will use this data set for some of the examples in this course, so it makes sense to download it and have it in the same folder where you have all your scripts. Okay, let me close it. Now I make a new script, which the second exercise in this learning sequence number 1, block 1. And then first of all, we need to load this data set. If you watched our basic course, you know that you cannot just load data from Excel file. You need a special package. This package is called read.excel. So first of all, you need to install it. You can do it in RStudio by going to package, click install, and then write read.excel. So this is the package. So click install. I actually already have it, but I'll just install it anyway. You can see install package read.excel. Now it's installed. So now I can use it. So first of all, I load it. Library read.excel. So I tell R that I'm going to use this package. And now I can read this data from this file, from people XLSX. I will use variable D for that. And then the function that reads, it's just read Excel. I need to specify the file name. And then because in this file I have only this table, I don't have anything else, so I don't need to specify additional arguments. Otherwise, you can also specify which worksheet and range and all that kind of things. So if I run it, you can see I have 32 observations of 13 variables, and it's just a table. It's actually it's a special format. It's called table, but we will convert it to data frame in a minute. Then you can see it's a set of columns. Most of the columns are numeric except names. And then every column has 32 numeric values. I will convert this to data frame. It's not necessary, strictly speaking, but I like the simplicity of data frames. And now let's analyze this data. Okay. First of all, if you just write summary D, you will get a funny representation. Actually, what it does, it takes every column and run summary, as we also used in the previous example, for every column. For example, you can see height, smallest value, first quartile, median, mean, third quartile, and max. And then it does it for every value here. Okay. Now you remember that some of these variables are actually qualitative. For example, sex, it's males and females, right? But in our case, it's represented as numeric variable. So let's make it a qualitative variable. This is how to do it in R. You need to say, take a column 6, and then you need to write factor. If I just run it, you can see I will get just the same values, but as a factor. You can see now it's levels, -1 and +1. So it understands that now it's a qualitative variable with 2 levels, so 2 categories. So it's a categorical variable with 2 categories. What I can do, I can provide names of these categories. I can provide labels equal to, I know that -1, the smallest one, it's male. So I will just write M, and the largest one, the +1, it's female, right? So if I run it now, you can see instead of -1, I have M. Instead of +1, I have F. So male and female. And now what I'm going to do, I will save this back to the column 6. You can see I take values from column 6, turn them to factor, and then I save them back. So you can see before I run it, my column with biological sex is numeric. You can see it here. But if I run it now, you can see now it's not numeric anymore. It's a factor with 2 levels, M and F, and inside it's just the coded 1 and 2. So M is 1 and 2, F is 2. Okay. So now what it gives me? It gives me a possibility to make groups. For example, when I make a box plot, I can write the following. I can write, for example, beer versus sex, and then data equal to D. What it means? Well, first of all, this little tilde, it's a relationship. So it means that investigate relationship between variable beer, which expect to be numeric, and variable sex, which is expected to be categorical. So strictly speaking, what boxplot will do, it will take all beer values and split them into groups according to the categories in sex. So we will have beer consumption for males and beer consumption for females. And this extra argument, data equal to D, it tells R, beer and sex are not variables. So we don't have, if you look at the environment, you don't have beer and sex as variables here. They are columns of data frame D. So it will understand that beer and sex are columns of this data frame, right? Let's see what it does. So if I run it, you can see a box plot. Now it has two boxes. So you can see variation of beer consumption for males. You can see beer. This is liters per year. And this is variation of beer consumption for females. Indeed, we have kind of a difference, right? Of course, if it's important difference or not, that's something that we will discuss later. Now we just describe the data. We try to find some patterns. We try to find some numbers that summarizes this data. Now, what if we want to compute quantiles, quartiles, median values, but separately for males and females? Of course, you can first split your data frame to males and females. That's what you also I taught you how to do it in our basic course, but actually in R there is a better way to compute statistics for groups, and this way it's called aggregate. So you can write function aggregate. You can write this exactly this formula. Everything should be the same. So I say beer, sex, relationship, and so on and so forth. And then you need to add additional argument, which statistics to compute. For example, median. Yeah, median. And then look. I compute median beer consumption for males and females separately. So you can see that males, the median beer consumption is 309, and then for females, it's 202. I can also compute, for example, quartiles or quantiles. So I can, let me start with simple mean and max. Mean and max. So you can see now we have, this is the smallest, this is the largest, right? If you want to compute quantiles and quartile, for example, the first quartile, then you have a little bit a problem because you don't have a function that computes first quartile, right? So you have a function that looks like this, quantile, but then you need to provide this x and p equal to 0.025, right? So this will not work. You can see it doesn't work. What you need to do, you need to create your own function. You can say function, for example, let's look like this. Q1 equal to function x, and then quantile x 0.25. So I create a special function which takes only one argument x. It doesn't require the second argument, and then it computes the first quartile for x. So first I run this line. You can see Q1, now it's a function, and then I simply put this function here, Q1, and then you can see that's what I get. Of course, you can try to put a function summary here. Let's see what it says. And then you can see that indeed we got all the summary values for every category. For males, mean, first quartile, median, mean, third quartile, and max, and also for females. So aggregate is very, very powerful from this point of view. Let me show you how to combine several categorical variables. So you remember that we also have, if I show you these variables again, you can see that we also have a categorical variable region, -1 for Scandinavian region and +1 for Mediterranean region. Let's do the same trick. Let's turn this into a factor. So I say D region equal to D factor, D $region, and then I need to provide the category labels, right? So labels equal to C. I know that -1 is Scandinavian and +1 is Mediterranean, right? So again, what it does, it takes all values from region. Now these values are numeric, -1 and +1. It turns these values into categorical variable with two levels. The name of the first level will be S, it will correspond to -1, and the name of the second level will be M, the second category. And then the result of this function will be saved back to region. So I change the column region here, right? So again, before I run, it's numeric. Now, if I run it, you can see now region is a factor. So it's not numeric. Now we have two factors, sex and region. Now look what I can do. First of all, I can make a box plot where I can say, for example, beer consumption versus sex plus region. So now it will take combination of these two categorical variables. So it will take males from Scandinavia, females from Scandinavia, males from Mediterranean region, and females from Mediterranean region. And for every group, it will create a box plot. I just need to say that these are columns of data frame D. And look, this is it, right? So you can see the code. Males from Scandinavia, females from Scandinavia, males from Mediterranean region, females from Mediterranean region. And you can see a very interesting trend. You can see now a very clear difference between the males and females in each region. But you can also see, for example, males in Scandinavia drink more beer than males from Mediterranean region, and the same for females, right? So you can see that this very simple plot can provide you already a lot of information, a lot of insights, what is going on inside your data. Similarly, you can use aggregate. For example, let me just copy and paste this. And then I simply say sex plus region. So it will create 4 rows. And for every row, it will compute a summary. So we have like a summary for males from Scandinavian region, the smallest, the first quartile, the median, and so on. And then females from Scandinavian region, male from Mediterranean region, and female from Mediterranean region. You can see all statistics computed at once. Okay. So that's actually it. So now we know how to describe data using rank-based description. We know how to compute statistics based on ranks. We know how to make different plots, how to visualize these statistics. And remember that this way of describing data is called non-parametric approach, right? So it does not require, it doesn't have any requirements about the data quality. It's based on ranks, so it's very simple and straightforward. The only drawback of this way to describe your data is that it requires sufficient number of values, like 10 values, 15 values or more. So if you have like 5 value sample of size 5, you can use it, but it will not provide you a good description because it's difficult to compute percentiles based on 5 values, right? So in the next learning sequence, we will learn an alternative to the non-parametric description, which is parametric description.